class, in this lecture we are going to go over section 3 for your lab 4 assignment for this week. And this is the first time you've done any hypothesis testing, and so I thought it was important to at least walk you through the steps in this first lab and help you to understand how we're going to be utilizing the Excel files of data that we are given, and how to navigate the HCUP website, how to complete the 5 steps in hypothesis testing, and how we come to our conclusions. So for this specific section of the lab, you are going to get some step-by-step instructions so that in hopes that in future weeks when we are working on other labs, you can get through them a little bit easier on your own. So what we're going to start off with here is I'm going to kind of go back a little bit in your textbook. Your textbook kind of goes over some of the basic statistics that we learned in the first of the semester. Average daily inpatient census, I think it's got some examples for calculating that. Inpatient bed occupancy rates, remember a rate is a percentage. Proportions are percentages. Inpatient bed occupancy rate, those things are some of the examples that are given in your book of how to calculate those statistics. Again, we did those earlier in the chapter or earlier in the semester, so that's not something we're going to focus on so much right now. What we are going to focus on throughout the rest of this semester, we're going to focus on different types of hypothesis testing. And your book talks about hypothesis testing in here. It looks like starting on page 65. And so I would really suggest that you read that portion of your text a couple of times. There are 5 steps in hypothesis testing, regardless of the test that we're using. Number 1 is determine the null and alternative hypothesis. So basically, you're creating that null and alternative hypothesis based on the questions you're asking. And we're going to go through an example here in just a second. Set the acceptable type 1 error or alpha level. For everything we are looking to see if 2 things are equal, or if our proportion in this case is equal to a US rate. So we're always going to have the same alpha level or type 1 error, and we'll get into a little more explanation on that a little bit later. The next step is selecting our appropriate test statistic. For the sake of this class and the information that you're learning, other than on your final project, the test statistic is given to you. I tell you what test statistic you're using. Then once we select our appropriate test statistic, we plug in information to the formula for our test statistic, and we make those calculations. Once we make those calculations, our 4th step is comparing our test statistic to our critical value based on the alpha level that we chose earlier. And then step number 5 is where we make our decision about what the test says. Whether we reject the null hypothesis if the calculated test statistic is more extreme than the critical value, and if not, we do not reject the null hypothesis. And again, I'm going to kind of help you through that process as we go through, especially this first test that we're calculating. here we're going to look at proportions, and for this specific example, we are looking at the mortality rate. And if you'll remember in the last lecture that I walked you through, we talked about those coded variables in our data set, and under the discharge destination, those are coded variables, whether the patient went home, whether they went to another facility, what type of facility they were discharged to, or as an inpatient if they died. So we're looking at just specifically the percentage of patients that died during their hospital stay. For the sake, again, of what we're doing here in this class and understanding just these basic tests and hypothesis testing, statistical tests that we're doing, we are always going to be doing a two-sided hypothesis test. This is where the null hypothesis, and the null hypothesis means that the two things are equal, and the alternative hypothesis says they're not equal. There's an example of this, these hypothesis statements on page 75. And again, it walks you through those 5 tests. So now we need to take a look at our data set, and we need to do a few things to get to where we need to be. So the first thing we need to do is find out of the patients in our data set, which ones were deceased. So we are going to populate a field here called death, and this is going to identify our patients in our data set that died. So here we're going to need to create a calculated column, and we're going to do this by creating an if statement. And that if statement is going to be if field J, column J, is equal to 20, because remember our, just a little bit ago we looked at, or in the previous recording, we looked at our data dictionary, and I'll pull it over here. If our discharge code, that coded variable that's in that column, if it is 20, remember this right here, that means the patient expired while they were an inpatient. So their discharge status would be death, or expired. Okay, we're going to pull that back up. Oops. So what we're doing here is we're creating an if statement that if column J is 20, it's going to populate a 1, and if it's anything other than 20, it's going to populate a 0. So our if statement would be equals. All of our formulas, any formulas in Excel have to start with a equal sign. If, and we're going to double click on that, and it's going to open up some parentheses. If, and remember, we're looking at J, field J, so if J2 equals, and we need to put these in quotation marks, 20, comma, it's going to populate a 1, all others is going to populate a 0. So it's going to be quotes 20, end quote, comma 1, comma 0. And in order to get this formula to compute, we have to close up the parentheses, and we're going to click enter. And here you'll see our discharge for this patient was 606, and our column here should have populated a 0, and it did. So we're going to copy the same formula all the way through our data set. We can do that by going to the far right hand corner, and when we get that, that crossbar symbol, we can click on that and drag this formula all the way through our data set, our 390 patients, I think. Okay, so we can look here and we've got lots of zeros, which that's a good sign. But right here is a 1, so we're going to go over and look, and we can see that discharge destination is of 20. So it looks to be like our formula worked. Let's go up just a little bit farther and see if there's any more 20s. There's another one right there. Okay, so for our entire data set, and again, I should have froze that top row. View, freeze panes, freeze top row, and that way as I scroll down through my data set, it keeps that top row intact. Okay, so now what we need to do is separate that information out. So we're going to do that by creating a pivot table. And we're going to insert pivot table. And if you'll notice, the pivot table wizard already automatically includes all this data that's in our data set. And that's the way we want it. We want it to populate in a new worksheet, so we're going to click OK. And now you'll see we have our headings for our pivot table. So now we have to create our pivot table, and we can do that by, remember, we're wanting to look at a specific DRG code, diagnosis related grouping code. So this separates out our three DRGs for the data set. And then we are looking at our columns. So the other information we want to look at is death. And we also want I put that in the wrong place. We want it as our column headings. So we want to separate out our patients that have died and our patients that didn't die. And now we want our patients. And remember I said last time it automatically sums it. We can change that value field to count. So now as we look at the data set, or the pivot table provided by the data set, we see DRG 291. We have 149 patients that didn't die. We have 16 patients that did, with a grand total of 165 patients for that data set. And this is the information here that we are looking at specifically for this for the specific question, because we're looking at the mortality rates, the mortality rate for our MS-DRG 291. Okay, so now what we're going to do is remember we're wanting it as a proportion, and since this is such a small data set, for this there's only 165 patients in this data set, we could probably calculate that percentage pretty easily by ourselves. But the good thing about the pivot table is it will calculate that for us. So if we go to value fields, and we want to show the value as a row total, percentage of row total, and you see here we get that calculation. So we know our mortality rate for MS-DRG 291 for our sample set equals 9.70%. And if we want to convert that to decimals, it would be 0.0970. Okay, so now what we need to do is find our, need to find the, go back and look at our instructions. We are making a comparison from our DRG, from our data set, the information from our facility, and making a comparison to the mortality rate for the U.S. rate, the mortality rate. Okay, so we're going to go to the HCUP website. This is something you guys kind of played around with a little bit the other day. And I'm going to pull that website up for you. Okay, we're going to see if we can walk through getting this information. We are going to be using this data, or this website. We're going to be using it weekly. So get really familiar with going in and looking up information. So I think your instructions say, let's look here. Your instructions say, calculate the mortality rate for the sample of patients discharged with MSDRG 291. So we just did this. So number one, the answer to this is going to be 9.70% or 0.0970. So now we're determining the mortality rate for the MSDRG 291 for Medicare. Remember, we're looking for a specific payer. Medicare patients in 2011 from the HCUP website. So we are going to go to our HCUP website, and we're going to click Create New Analysis. Inpatient stay, we want descriptive statistics, and remember our instructions told us 2011, and we want specific to a disease, conditions specific to a disease, and we want to choose our classification system. Remember, we have the MSDRG code, and if we enter that here, 291, and we only have the one code, we're wanting to create our analysis. We have to accept the data usage agreement. Okay, so here we have to pick exactly what we're wanting from this DRG set, from their information. So we're looking at outcomes and measures. And we're wanting a rate. Remember, we're wanting that percentage. And we want the percentage of patients that died. And the other thing we're looking at is, remember, it said Medicare patients. So we want to look at payer information. And then, let me move this up a little farther, maybe. It's got a button. I don't think you can see it on the screen. To the left, it said Submit Request. And let me shrink this back. Okay, so now remember, what we're looking at is the U.S. rate for Medicare patients for 2011. We're in 2011 National Medicare Severity Diagnosis Related Groupings for DRG code 291. And that stands for heart failure and shock with MCC, major complication and comorbidity. We're looking specifically at Medicare information. So we're going to compare our rate. So we are just wanting to compare our rate to that of this, the 5.96%. So that's going to be something that you're going to have to document. So we are going to go back to our document here. Let's go back to our Word document because I want this all submitted as a Word document. So this rate should be 5.96%. or 0.0596. Okay. So here we're, the next thing we're doing, once we have that information, the next thing we do is we identify what would be our null and alternative hypothesis. And remember I said earlier, for the sake of what we're doing in this class, we are always looking at whether something is equal to something else. That's how we're basing our tests. Our null hypothesis is our proportion, so that's the P, equals 5.96 or 0.0596, because this is the number you're going to need to plug into your formula. Our alternative hypothesis is that they are not equal. Our proportion is not equal to 5.96. So what would be your guess at this point? If our proportion or our rate is 9.70 and the national statistic, their rate or their proportion, mortality rate for patients with this DRG is 5.96. So that would tell me that possibly we're in a situation where our mortality rate, to the eye, what we're looking at is it looks like our mortality rate is higher than that national average. So as we select the appropriate alpha level, or what we're making our comparison to, for this class, we are always going to use the a two-sided test, so that's going to be a 0.025, and so our critical value is going to be 1.960. And I will explain to you here in a little bit how we use that in making our determination. Okay, so here is our formula. Z equals our proportion subtracted by the standard. What's the standard rate? The proportion. Divided by the standard proportion times 1 minus that standard proportion divided by n. N represents the sample size. So for DRG 291, our sample size was 165. So here is where we plug in all of our information. Our proportion is 0.0970. The US rate, which is P0, is equal to 0.0596, and our sample size is 165. So here we will do those calculations, and you should, let me see if I can do some quick calculations, or if I have it written down here. You should get a calculation, your Z, should equal something close to 2.029. Depending on how far out you hold your decimal place, or how far out after the decimal place and where you round, you should get a Z somewhere close to this. Remember, you have to do order of operations, so you should do the 1 minus 0.0596, then you should take the 0.0596 times whatever the answer is to this, then divide it by the 165, then take your square root after all that is done. I want you to walk through those calculations. You will be required to do these calculations yourself, so I really suggest practicing doing them with this one. If you get stuck somewhere along the way and can't get an answer that's very similar to this, send me an email with the work that you've done, and I will give you some feedback and try to help you along with that. Okay. So now is the point where we take our critical value, which we looked at it right here. It is the 1.960. So what we do here is we want to see if our z-statistic is within a certain range. So we have 1.960 to a negative 1.960. So how you're answering the question is you're taking your z-statistic and comparing it. Does it fall within this range, 1.960 to a negative 1.960? If it falls within this range, if it falls between 1.960 to a negative 1.960, you would not reject the null hypothesis and state that there's no statistical difference between your proportion and the U.S. rate. So which would say basically that what your proportion is in line with what that U.S. rate is. If your z-statistic is greater than the 1.960 or less than the negative 1.960, so if it's more extreme than your critical value, then you would reject the null hypothesis. Remember, the null hypothesis is that they're equal. You would reject the null hypothesis. And conclude that our mortality rate for MS DRG 291 is statistically different than the national rate. So we can see here, for this, our z-statistic, let me make that a little bit bigger too. Once you've done your calculations, we can see that our z-statistic is 2.029. That is greater than the 1.960. So this is our okay range. If it falls within this range right here, the 1.960 to negative 1.960, then we would say they're statistically the same. If it falls outside of that range, then we're going to conclude that it's not statistically the same. There is an example in your textbook. For the example in your book, they come up with a z-statistic of a negative 1.36. Again, and for this one, that is not more extreme, and therefore they would not reject the null hypothesis. You know, again, it's taking your sample and basically leveling the playing field, because the sample set that's provided to the HCUP is so much larger than the sample size that we're comparing it to. It's not really comparing the same things. So we have to do this calculation with the z-statistic to see how it actually plays out. And here we can see that our z-statistic is more extreme than the critical value range. And therefore, we would conclude that they're not statistically the same. So on your assignment sheet, I need you to go through steps 1, step 2. Step 3, I want to see you write out that null and alternative hypothesis. I want to see at least some kind of calculations for your z-statistic and how you went through the steps of calculating that z. And then you should come up with the same answer that I did. If you do not, then I would say you need to send me your work and I can help walk you through it. If you have questions, be sure to let me know. I want you to, as you're going to need to manipulate your data sets the same way I did. You're going to need to be able to get comfortable with that. So make sure you take the time to do that along with me. Don't just follow along with what I did. Take the time to go through the data set and do your calculations, because you'll be expected to do those in future labs. If you have any questions, please be sure to let me know.